What's up, everyone? Today we are going to factor when our leading coefficient is not 1. So this is the most complex type of factoring we're going to do. And go back definitely and check out the previous 2 videos if you haven't already to see kind of the lead up to today's type of factoring. So I have been working through these factoring lessons through the lens of the intimate connection between expanding or distributing or multiplying, say, 2 binomials, and then trying to do that in reverse, all right, the inverse operation of that being factoring it, to rewrite that as a product of factors again. And so that's actually where we're going to start today, because I want you to be able to see if I expand these 2 binomials here, what happens and how can we use that to kind of reverse engineer the process and get back to this factored form. So I'm going to start by double distributing. Really means I'm taking this 3x and multiplying it by this whole binomial here. So I don't normally write it out this way, but essentially this is what's happening, right? I'm taking 3x and multiplying it by this binomial 2x minus 1. I'm taking this 5 and multiplying it again by this binomial 2x minus 1. All right, so now, right, let's fully distribute here. Right, so this is going to look like 6x squared minus 3x plus 10x minus 5. All right, so we've distributed. Last thing is we have these like terms here that we're going to want to combine. So we're going to be left with 6x squared, and then we'll have plus 7x minus 5. And that is our standard form here. So x squared plus 7x minus 5 and 3x plus 5 times 2x minus 1, those are equivalent, right? They're just different ways of writing the same expression. And so let's go back and think, well, what have we done, right? If we were trying to reverse engineer our steps, what do we do here? Well, the first thing we did was we distributed, right? So we've got this distributive property. And then we had to combine our like terms. So what we need to do here, if we are working in reverse, is we're going to uncombine, if you will. We're going to need to figure out how to split 7x back up into such a way, into 2 terms, that we can factor 2 GCFs out to the beginning, right? In this case, 3x and 5, and then 1 large GCF that will come out at the beginning. And we'll see more what that looks like in a second. So remember these steps for factoring here. I've kept the same for all types of factoring, right? To begin, we are going to rewrite our equation if necessary in standard form. We always want to make sure that we are starting in standard form, and if possible, we're going to factor out a greatest common factor, or GCF. Then we're going to notice the value of a. So when a is not 1, okay, also not 0 because then it wouldn't be quadratic trinomial, but when a is not 1, we're going to use this method known as factoring by grouping. And so what factoring by grouping does is, this is where we're splitting into 4 terms, right, after we've uncombined that like term in the middle, and then we're going to take out a bunch of GCFs. So how it goes is we, right, are working backwards. Rather than looking for factors of C that add to B, we're looking for factors of A times C that add to B, because now we have this a little bit more complex situation going on with that leading coefficient. So we are working backwards. Ooh, probably don't want to write my notes all in highlighter. We are working backwards. So first things first is we're going to uncombine. I do literally write uncombine because it makes me laugh, and that's what we're doing, right? AKA separate. bx into two like terms using our chosen factor pair. All right, then what's going to happen is we are going to factor out a GCF three times. The last one's going to be a whole binomial GCF. It's super, super big. All right. Let's see this in action. So, first things first is rather than look for, okay, hold on, really quick. This is in standard form. There's no GCF. Good. Rather than look for factors of C that add to B, we are looking at factors of A times C. So we are looking for factors, of this case, of 6. So factors of 6 are 1 and 6, and 2 and 3, the ones that we just used. And then we want to know which of these guys here adds to 5x. Well, it's going to be 2 and 3. So I'm going to split this middle term into now plus 2x plus 3x. And then I'm going to bring down everything else. So we still have 2x squared and 3. Right, so that's our first thing, is we had to kind of uncombine our like terms there. Now, what I'm going to do is I'm going to think about these separately. So almost like I'm drawing an invisible line here, I want to think about this first half and this second half separately. So I sometimes have my students cover it up, right? Maybe I take my highlighter, turn it black, cover that up for a second, right? Pretend it's not there. And I'm going to think about what is the greatest common factor of 2x squared and 2x. Well, it's going to be 2x. It's the biggest thing that I can pull out of both of those. And what's left over is x plus 1. Make sure you have that plus 1 there as a placeholder. When you, if you were to check your work to distribute 2x back in, we should still have 2 terms. All right, well now we are going to ignore the first 2 here and think about the last 2. So we've got 3x plus 3. So 3 is something I can factor out here, and so end up with x plus 1. All right, so what I want you to notice here is that these both, whoopsies, have this factor of x plus 1 in common. So right now what I have are 2 terms, okay? They're chunky terms, but 2 terms, and they each have x plus 1 in common. So what I'm going to do is I'm going to take these and I'm going to factor them back out to the beginning. So what that's going to look like is x plus 1 is going to come out front here. And then what's left over is going to be 2x, right? The things that were out front, and 3, like so. Now, if you're thinking, Kaylin, I don't know. That is totally valid, totally valid. And so let's go ahead and check our work. So if we're checking our work, we're just going to foil or double distribute this back out. Alright, so I'm going to end up with 2x squared plus 3x plus 2x plus 3. So 2x squared, combine those middle terms, we're going to get plus 5x plus 3. Sorry if you hear that weird noise in the background. We live in the woods, and so it's mostly quiet, but every once in a while nature just kind of takes over here. Oh, and lo and behold, that's what we started with. So we know that we are done. We can box up our answer. All right, next. 4x squared minus 9x minus 28. So again, this is in standard form. Doesn't look like there's a GCF that we can factor out. So we are going to look for factors of 4 times negative 28. And so that's going to be negative 112. And so this is where, right, it's okay if you need to use a calculator. I always tell my students that you're going to accidentally get really good at your multiplication tables, right, and start memorizing some of these factor pairs even without trying, because you're just working with them so often. All right, so I've gone ahead, written a bunch of possible factor pairs for 112, but notice it multiplies to negative 112, and so that means one of our factors is going to be negative. And because we end up with negative 9 here, we know that the larger factor is negative. So I'm just going to go ahead and add those negatives in. And now we're looking for what adds to negative 9. All right, it's going to be 7 and negative 16. So I'm going to start by splitting negative 9 into plus 7x and minus 16x. Gonna leave everything else the same. So this is minus 28. This is 4x squared. All right, so now comes, right, where we are kind of chopping this problem in half. We're gonna think about what's the biggest thing that goes into both of these, and then we'll worry about the biggest thing that goes into both of these. So again, if you need to, kind of hide the second part of the problem for a second and only look at the first part. The biggest thing that goes into both of those is just going to be x, because 4 and 7 don't have anything in common. Alright. Next, we're going to ignore the first two, the 4x squared and the 7x, and we'll think about the greatest thing that goes in here. Now, something that's important is when both of these, or actually whenever the first term here is negative, we don't like negatives at the beginning of our binomial, so we're always going to take a negative out along with everything else. So 4 is the biggest thing that goes into 16 and 28, and then we're going to take out negative 4 so that our leading term can be positive. So this will become 4x plus 7, again, because of that sign change there. And so now I've got x times 4x plus 7 minus 4 times x plus 7. Alright, and remember now this 4x plus 7 and this 4x plus 7, those are our GCFs that we are going to factor out to the beginning here, because they both have that factor in common. So this is going to look like 4x plus 7 times x minus 4. And again, multiplication commutes, so it's okay if you convert it the other way. Maybe you kind of thought about factoring out to the right instead of to the left. That's okay. All right, and at the same time, we're not going to double check our work on that one, right? But go ahead and move on to the next. And trust me, I gave you the right answer. All right, next we have 6x squared plus 11x plus 4. Again, no GCF here, so we're just going to jump straight into 6 times 4. Gets us 24. We want to be thinking of factors of 24. So 1 and 24, 2, 12, 3, and 8, 4, and 6. And then we want the ones that add to 11, so it's going to be 3 and 8. So this will split up into 3x plus 8x plus 4, like so. Alright, so we're going to factor out a GCF from the first two terms. That'll be 3x, leaving behind 2x plus 1. Then we'll be able to take out a 4, again leaving behind 2x plus 1. And so now these are our one big GCF that we're going to factor out to the beginning here. So we'll have 2x plus 1, and then we'll have 3x plus 4. Gorgeous. Alright, last one we're going to do together, and then I'm going to give you some practice, okay? So we've got 5x squared minus x minus 4. 5 times negative 4. And get us negative 20. So, negative 1, 20, negative 2, 10, negative 4. We're looking for the ones that add to positive 1. So it's going to be negative 4 and 5. So this is going to look like 5x squared minus 4x plus 5x minus 4. We can factor in x from the first one, so we'll have 5x minus 4. And we can't factor out anything from the second one, so we're still going to write it this way, plus. Maybe it's helpful the first couple times if you put a placeholder 1 here to help you out, to see that here we still have this factor of 5x minus 4 that we're going to factor out to the beginning. So that's going to look like 5x minus 4, and then we'll have x plus 1. And that's why I put that plus 1, to make sure that I still had a binomial after I factored that out as a little placeholder. Alright, so on the back, I gave you loads of practice problems. Notice I've got my answers all covered up because I want you to go ahead, work these out on your own, and then come back and we will check your work. Alright, welcome back. So, first things first, we've got this problem here. We are looking at 3x squared minus 7x plus 2. And so what's going on here is I knew that I was looking for factors of 6 that add to negative 7. I went with negative 1 and negative 6. Split that apart, did my 3 GCFs, and I was able to get 3x minus 1 times x minus 2. Alright, on the next one, we did 3 times negative 20 to get negative 60. We were looking for factors of that added to positive 11. So we knew that my smaller factor was the negative 1. And so I went with negative 4 and positive 15. And so I have 3x minus 4 and x plus 5. Next, we had 4x squared minus 25 plus 25. So this one is tricky because at first you might be thinking 4x squared, 25. We've got that positive b value. Those are both perfect squares, but this does not have 2ab in the middle. And so, unfortunately, this was not a perfect square trinomial. And so when we factored this out, we ended up with 4x minus 5 times x minus 5. Finally, here in H, we had a GCF that we could take out to the beginning, so we needed to factor out a 2. Then we looked at factors of 4 times 3, using the factored trinomial here. To get 12, we wanted factors of that to add to 7, so we went with 3 and 4. We ended with 2 times 4x plus 3 times x plus 1. Make sure you're carrying that 2 along all the way down, and that your GCF doesn't disappear on you. Alright, so far so good, guys? Let's see, 2 more and then we are all done. So here we did 6 times 24, and we got 144. This was fun. So many factor pairs here. We went with -9 and -16 because that adds to -25 but multiplies to a positive 144. So when we factor that out, we ended up with 2x minus 3 times 3x minus 8. The last one here had a negative GCF. Remember, we always like our leading term to be positive, so we factor out a negative here. So that changes every sign in the trinomial, so we end up with positive 3x squared minus 2x minus 1. Here you'll notice I didn't write factor pairs down because 3 times -1 is -3, which is prime. And so we knew that aside from moving around the negative, we were limited in our options here. So we went with -3 and positive 1 because when we added those together, we got -2, which is what we were looking for as our B value. Then we went ahead and factored. Notice again that I carried this 1 all the way down, so I didn't forget about him. And we end up with negative times x minus 1, 3x plus 1. All right, everyone, that's it for factoring. You did it. I'm so proud of you. See you later.